So for the first one, we have, I made a box. You don't have to make a box. You can use foil. You could distribute, whichever way you want to do it. So we have 3x squared here, negative x, 1x here, a positive 6x here, and a negative 2. The one thing I do like about the box is that your like terms are at a diagonal. So these are like terms, so we can add those together. So the final answer that I'll be looking for, if this was on the skills check tomorrow, would be 3x squared plus 5x minus 2. All right, who had that? Any questions? All right, for the second one, it's asking us to find f minus g of 0. So it's asking for a different operation. So the shortcut, or one way to do it, would be to find f of 0 and then subtract from that g of 0. So let's find f of 0. F of 0 would be 3 times 0 minus 1. G of 0 would be 0 plus 2. So 3 times 0 minus 1 is negative 1. 0 plus 2 is 2. And now we need to subtract these numbers. So my final answer would be, because it says f minus g. So it's negative 1 minus 2. So what would be your answer? Who got negative 3? Now, if you decided to figure out what the f minus g function, and then put the 0 in that, you will still get negative 3. All right, so now let's go to the two images that I had you glue down yesterday. So you should move so you can see. Well, then move. There's 2 open desks right there. Yes.
Is this 2.1?
This is 2.1. Yeah, this is 2.1. Okay. So you don't have to write this down, but we're going to look at a graph and figure out where it's increasing, decreasing, or constant. Okay. So looking at those two examples, we're going to look at it and figure out. So example 2, you should already have it glued down. We're going to figure out where is the graph increasing, where does it decrease, and where is this constant. So you just need 3 lines. When you write the intervals, you're going to tell me the x values, okay? I think I added it on yours. I'm not sure if I did. Genesis, can you put that up for me? I think I added. Did I put arrows on your graphs before I made copies? Did I put arrows on it? All right, can you add arrows? I meant to do that. So there's an arrow that goes this direction, and there's an arrow going that direction. Go ahead and add that to your graph. All right, when you read a graph, you're going to read it the same way you read a book. You're going to start with the left side and trace to the right side. So everyone, this left arrow, the left arrow is always negative infinity. So this left arrow represents when x is negative infinity. The right arrow is when x is positive infinity. All right, so let's get started. When you look at the screen, you all see my little laser here. What am I doing? Is my little red dot going up or down? So that means that this graph is doing what? Increasing. So this portion of the graph, I'm going to highlight it in green. This is increasing right here. So it increases from negative infinity, because we started with the left arrow, and it stops when we get here. What does x equal right here?
1.
So this is the x and y right here. So right here would be what? 1. So it increases from negative infinity to 1, put a parentheses. Then when we get to 1, If you look at my cursor, notice it's just going straight. It's flat. So what do you think that means? It's what? Constant. It's constant between here and here. So it's constant between 1 and 2. And then when you can look at my red arrow. What is it doing now? My little red dot is going decreasing. So it decreases from 2 until 3. And then starting at 3, it increases again. So that's all you're doing. You're just looking at the graph and telling me the intervals, the x intervals, when the graph is going up, when it goes down, and when it's constant. That's it. That's all there is to it. All right, let's do the same thing for the second one. Wait for what? All right, so we have a negative infinity here and a positive infinity on the right. This one doesn't have any constant, so I'm just going to write increasing and decreasing. Because this one does not, it's never flat. So I want you to look at this graph. There's 2 places where it is going, 3 intervals where it goes up and 2 intervals where it goes down. So if you want to, because I don't want you to get confused, we're not this one was helpful because it gave us the ordered pair. We're not looking at the y. So if you want to cross those out so you don't accidentally use those numbers, do that. Because you're only looking at the x value. So I'm going to give you about a minute to try and write those intervals. So there are three intervals where it's increasing, 2 intervals where it decreases. I'm going to trace them. So this is increasing. So this part of the graph is increasing. This would be increasing. This is increasing. And it decreases from here to here and from here to here. Who had that? All right, so let's go ahead and write them as intervals. So we start to increase initially at negative infinity and we stop at -3. Then at -3, it starts to go down, and it goes down between -3 and -1. Then at -1, it goes back up, and it stops going up when we get to +2. At +2, it goes down again till we get to 4. And then my last one is an increasing interval from 4 to infinity. That's increasing and decreasing. So that is on the test. You have to tell me the intervals where it goes up, increases, and when it goes down, decreases. Yes.
So we never look at the y.
No. So you might want to write that down somewhere, that when we're talking about increasing and decreasing, this is only the x values, only x values. So write that down. Anytime you're asked for increasing and decreasing, that's the x values only.
And there's no brackets in this.
Yeah, there's no brackets because it changes at that point. So we're only going to use parentheses. Good questions. These are really good questions. All right, so now the last thing we're going to talk about is finding our maximas and minimums. All right, so let's go ahead. I'm going to give you some definitions that maybe you can put somewhere. But the absolute max is your highest point. You could put this anywhere. So the highest point. And an absolute minimum is the lowest point. Not all graphs have both. A local max, I'm just going to write on top of my little image. I like to think of that as a hilltop. And the local min, that's a valley or a dip. Okay, so that's my non-mathematical definitions. There's some mathematical terms, but I think that's the easiest way to think about them. Do you all remember this from Algebra 2? Seeing this in Algebra 2? Okay. So I'll give you a minute to copy that down, and then I'll erase it, and we'll start going through them. So with the quiz review, you can do the majority of that review already. I would recommend that you start it. I mean, I hate to give you homework over Labor Day weekend, but on Tuesday, I'm only going to answer questions. And then Wednesday, you take a test. So if you come to class Tuesday and you have not looked at it yet, you're kind of at a disadvantage because you don't know what you don't know. So I really hate to do that to you, but if you want to make sure you do well on the quiz, because remember, quizzes go into 80%. Skills check and homework, that's 20%. But now we're going back to the big dog category. You might want to make sure you know what you're talking about on Tuesday, so you know what you need to focus on going into Wednesday. Okay, so that's why I gave it to you early, so you can at least look at it or try to look at it. I didn't want to wait till Friday to give it to you. All right, so do we have these 4 definitions copied down? Can I take them off? Anybody need more time? All right, so let's go. We're about to do it. Need some space. I don't know why my screen, okay, it don't want to go down for me. So I might have to erase one and then put it back. All right, so let me just take this one off since my iPad is not cooperating with me. You can write it below, but usually my iPad will let me extend the screen down, but it's not letting me do that. All right, so for this graph, we're going to find the absolute max. We're going to figure out where is our absolute mins, our local max, and our local mins. Now, can you write? Now, when you're asked to identify extrema, this is going to be an ordered pair. So I'm looking for a point, XY. And I think I added this. Did I add arrows on yours? I think I added that before I made the copies. Okay. All right, so remember that an absolute max is the highest point. This side is going to go up forever. So if it's always increasing, if it's always rising, is it ever going to hit the top? So we don't have an absolute max. There is none. And the reason why is because we have an arrow that goes up. Anytime you have an arrow pointing up, you don't have a highest point. If I keep climbing, I'm never going to hit the top. Same thing with an absolute min, right? We have an arrow on the left that's going down. So we don't have one of those either. And that's because we have an arrow that goes down. So now all we need to do is identify the ordered pairs where we have a hilltop and a dip. So here and here, I'm going to put green dots. These two would represent my local maxes. So this will be a local max. And this is a local max. So let's go ahead and write those ordered pairs. So I have a local max, which is a hilltop, at -1, 0 and +1, 0. That's my local max. Show me with your fingers how many dips do you see in this graph? Everybody's seeing one. I see two. Look again. There's two. Yeah. There's one here and here. Go ahead and put points there. We call those a local minimum. Now, this is not really one of my favorite graphs because we kind of have to approximate it because they're not like on a nice solid point like our local maxes. So we're going to approximate it and just come to an agreement of what we think this is. So I'm going to call this point, even though it's a little bit on the negative side, I'm going to round it to a 0 and say that it's about a 0, -4. And the same thing when you actually take your test, if it's not like actually on a point, as long as you're close, then we're good. So 0, -3. And then right here in between, so you see how this is like halfway between. So we'll say this is about 2.5. And it's a little bit above -15. So we'll say that the second one is at about 2.5. I'm out of space. Oh, no, I'm not. -14. And that's it. Any questions? So I think these are easier when you have arrows that go opposite direction. It's a little bit easier because we already know we don't have absolutes. We only have locals. All right, so now let's look at the second graph. Does anyone need more time to copy down this one? All right, so now let's look at our second graph. So for this one, we do have an absolute. So let me go ahead and write that again. So we have our absolute max. We have an absolute min. We have our local max. And we have our local min. And I think I added arrows before I copied it, but you should have 2 arrows going down. So because we have 2 arrows going down, which one is going to be no? Which one don't we have? The minimum. So this is a no. We got none. NA, none, does not exist, whatever you want to say. All right, we do have a highest point though. Would you agree? We got 2 hilltops, but would you agree that one of these hills is definitely higher than the other?
Yeah.
All right, so this one we're going to call my absolute. That's my absolute max. So again, we're going to approximate this, and this is counting by 2s. I don't know, this is a horrible graph, but it's counting by 2s. I don't know if you can see that. So what do you want to call that point that I put the highest point? What's the order pair for that? -2, 8.
Yeah.
It's like -2, 9. But again, we just got to be in the neighborhood. We don't have to be exactly knocking on the door. We just got to be in the neighborhood. Okay, so -2, 9, -2, 8. We good. That's good. Okay. Now, if it's an absolute, every absolute is always a local because a local max is all your hilltops. Okay, so this point here, because it's a hilltop, this is also a local max. So that point is 2 things. It's an absolute and it's a local. But then we also have another hilltop. Now this is not the highest point, but it is a hilltop. So this is a local max.
So your absolute max will always be a local max?
Yes. Every absolute max is always a local max.
Same thing for the minimum too?
Every absolute min is also a local min. So the local min, we're going to call that, I'm going to round it to about 1, 2. All right, show me with your fingers, how many local mins do you see? How many dips? Yep, I agree, it's just 1. And that's right here, and it's lucky because it's at the origin. And that's that. Any questions about that? All right, we got time to do one more question. We're going to finish out 2.3 tomorrow, but I want to get you started with the last thing that is on your quiz. The last thing, and that's finding the rate of change, which is slope. So we're going to do one more question, and then we will be finished for today. So I'll give you a minute to copy this down. You don't have to copy down this formula because I think this formula is a little complex. How about we use the formula that we learned back in Algebra 1, which is m equals y2 minus y1 over x2 minus x1. So this is the same formula, except this is just written a different way. But this is this. But students find this to be easier to work with. So the main thing I just want you to write down is write down example 4. And write this down. And then this formula. And then we'll work through this together, and then we'll end there for today. Yeah, we're still in 2.3. This is the last thing for 2.3. The quiz is over 2.1 to 2.3. So this is the very last part of 2.3. And then after the quiz, we'll do 2.4 and 5, and then we'll take a test. So
The test is a week after, right?
I don't remember, but again, it's on Canvas. It's all on Canvas. I'm trying to remember because I teach this class and another class, and I know they have a quiz, a test on the 11th, but I don't think you do, but I really don't know.
I think our test is the 13th.
Could be. It's all on Canvas though. All right, anybody need more time to copy this down?
Yeah.
All right. Okay. So these 2 points that we have in these brackets, this represents my x1 and my y1. I'm sorry, take that back. These 2 points in our bracket represent our x1 and our x2. Those are both my x values. So we need to find the y value for both of these points. And to do that, we're going to do a substitution. So I need for you to pick up your calculators. Figure out what h of -1 is and h of +1. We're going to use this equation. So, and when you do it, please do not forget on the test to put your negative in parentheses. Because we have people miss 4 points on the quadratic formula because they didn't put parentheses around the negative. I don't know how to get y'all to do that. That's important. So you have to put a parentheses when you're putting an exponent on the negative. So go ahead, use your calculators and find these two numbers. Find h of -1 and h of +1. And I don't remember the numbers, so I need for y'all to tell me what they are. 6 and 2? Anybody else get 6 and 2? Anybody get something different? Okay, well, I'm going to go with it. 6 and 2. All right, so that means that these are our order points, our order pairs. So we have a point at -1, 6 and a point at +1, 2. So this would be my x1, y1, and my x2, y2. So now we just need to find the slope. So the slope is going to equal y2 minus y1 over x2 minus x1. Remember, when you subtract the negative, it becomes addition. So you should get negative 4 over 2, which is equal to negative 2. Who got that for their rate of change? All right, we're going to end there. Tomorrow, we're going to practice with the rate of change formula, but we have covered every single thing that will be on your quiz. So use this time, finish up homework 7, because that's due tomorrow, and look over your 2.1 for tomorrow's skills check.